Hello everyone, my name is Lei Zhang. I'm a PhD student in the University of Michigan School of Information. Today I'm very excited to be here to present our paper, Flowmatic, an immersive authoring tool for creating interactive scenes in virtual reality. This work was done with my awesome advisor, Steve Oni. So in recent years, virtual reality has captured the popular imagination in movies and has been a new medium for content creation. While the immersive experiences and intuitive interactions are compelling for end users, designing and building VR applications can be difficult and frustrating for novice programmers because it requires knowledge of not only 3D modeling, but also computer graphics, imperative programming, and reactive programming. Even visual programming languages built for non-experts, such as Unreal Blueprints, require that users have to mentally translate between 2D and 3D representations and predict how their code will execute in VR. Therefore, our main question is, what if the user can create, edit, and program the virtual scene while immersed in VR? This paradigm is called immersive authoring. Here is a film named World Builder from 10 years ago, where the main character has built a virtual world with natural interactions when immersed in the virtual space. 10 years later, we have made progress in immersive authoring tools in both industry and academia. However, a common limitation of existing immersive authoring tools is that they are not expressive enough to define reactive behaviors, a fundamental requirement for most practical VR applications. For example, commercial tools such as Google Toothbrush allows users to sketch a rocket, but it is not expressive enough to enable users to say, define when to ignite the rocket, the trajectory of the rocket, etc. Reactive behaviors are behaviors where the application responds to events like user actions, system events, or collisions. These behaviors are what make the VR scenes interactive. Therefore, we make the following contributions in our paper. First, we introduce techniques to raise the ceiling of the expressiveness of immersive authoring tools, including the ability to create reactive behaviors and to programmatically create and destroy objects in the scene. Our system is based on the concept of functional reactive programming and introduces the first visual representation of FRP primitives. We also introduce a set of dynamic operations, intuitive interactions, and visual representations for defining reactive behaviors. Our system is based on the concept of FRP, which models mutable values as time-variant data streams. The basic primitives in FRP are signals, which refer to continuous time-variant values, and event streams, which refer to infinite streams of discrete values. Let's use a simple example to illustrate the mechanism of our system. Let's say we're rock stars and want to do a rehearsal in VR. So the target behavior is to let the spotlight follow the user and switch the spotlight on and off using VR controllers. First, we have a light as a model and an avatar as a data source. Each model or data source will have a list of attributes such as position and light direction, and a list of methods such as light on and light off, which indicate the actions that an object can take. To do that, we first introduce a simple vector calculation of direction B to A equals position A minus position B. So here we have a subtract which adds an operator that takes two inputs on the left and produces the computational result as output on the right. So we first draw an edge from the position of the avatar to the input of the subtract operator. We then specify the minus input of the operator using the position of the light. Finally, we pass the output to the light direction, and that would make the light automatically follow the user. We can also make the light switch reactive using another data source, the controller. We can specify when the trigger is down, we should turn the light on, and when the trigger is up, we should turn the light off. And now, besides the light following effect, you can control the light switch in real time in VR, and the stage is yours. We implement this idea in VR, enabling users to compose such flow-based diagram in edit mode and to evaluate the application in real time in run mode. There are many more example applications that users can create using Flowmatic, demonstrating its expressiveness. With the time remaining, I just want to note that Flowmatic also introduces mechanisms for taking abstraction of notes, mechanisms for type visualization, and constraints. We also conducted a comparative study with A-Frame, a desktop authoring method. If you're interested, please see our paper and demo video for more details. Thank you for listening.